Here we have our states of matter exit ticket. Now, in this lesson, we completely characterize solid, liquids, and gases both macroscopically in what we could see and describe, and also microscopically, what the particles do and behave and how they're arranged in every phase of matter. And this exit ticket really went to summarizing the entire lesson, but charged you with filling in the blanks so that you could not just summarize but also check your understanding. So I'm going to go through and finish these statements for you. It says, our blank observation of a solid sample would allow us to describe it as having a blank shape and volume. So our observation of a solid sample describing us as having a specific shape and volume is something we can see with our eyes. That is macroscopic. And it would allow us to describe of a solid, is the other key word here, allows us to describe it having a definite or a defined shape and volume, one that does not depend on anything else. Though liquids have a definite blank, they don't have a defined blank. So what we just referred to in the last sentence was shape and volume. We know liquids take the shape of their container. But we talked about the fact that their volume doesn't really change no matter what container they're in. So they do have a defined volume, they do not have a defined shape. Oops, volume goes over here. They have a definite volume, they don't have a defined shape. It depends on the container. Gas samples blank any container. So what do we have? Oh, we have fill is a good option here. Gas samples will fill any container. And if we take the container lid off, they will fill the room. They fill. Gas samples fill any container and blank when the container is opened or broken. They escape. Because they have a blank volume, so an indefinite, the AN is a grammatical clue there that a vowel started the next word. Indefinite means not defined, ill-defined, not sure. Okay. We must remember, though, that there is a blank arrangement of particles that make up all states of matter. There is a microscopic arrangement of particles that make up all states of matter and ultimately produces what we are able to observe. First, particles of matter blank differently. This whole microscopic part of the lesson was about their movement. They move differently. The particles of a gas sample are blank and move blank. So a gas we reviewed have particles very far apart. They move very fast. Because they are very far apart, they have the space to do it. Then the particles of a solid sample, which only blank in a blank space. So the particles of a gas sample are far apart and move very fast, or that should say, I guess, faster, than the particles of a solid sample. So we know the solid moves slower, which only blank in a blank space. They only vibrate in a small space as opposed to a far apart space. The behavior of liquid particles falls somewhere between the extremes of solids and gases. The blank between particles is about distance. Allows or restricts their movement. The particles of a solid sample are closely packed, while the particles of a gas sample are longer distances. The particles of a liquid sample are spaced somewhere between what we imagine for the extremes of solids and gases. Now, some of those grammatically just sound kind of weird, but that is how they all belong. That is where they all belong. Maybe it would go like this. They're very far apart and move longer distances. That's what we want to do there. The particles of a gas sample are far apart. They do move very fast, but they also move longer distances. So it's not just about the fact that they move fast, but they also move big. They can go across the entire container. Whereas the liquid particles, they only move little bits. Then the particles, longer distances, and so there is our grammatical clue to the comparison to a solid. Then the particles of a solid, which only vibrate in a small space. Okay. And it says the particles of a solid sample are closely packed, while the particles of a gas sample are very fast. That doesn't seem right either. There's not an option for Well, the particles of a gas sample are very fast. That has to be correct. That is correct. Everything else there is perfectly positioned. So that's what we have. That's good. See? Even the teacher has to do some troubleshooting. I haven't seen this in a while. And the way some of the words are worded, it causes you to question or be more certain about your answers. But this is a great summary of what we learned about states of matter.